we need to talk about the star that gives us life, and how easily it could take that life away. Right now, 150 million kilometers above your head, the sun is burning. Not burning like a fire burns. There's no oxygen, no combustion. But fusing hydrogen into helium, releasing energy through nuclear reactions so powerful that a pinhead of solar core material would kill you from radiation exposure at 150 kilometers away. That star, that fusion reactor in the sky, is not stable. It's not calm. It's roiling with magnetic fields and plasma currents, with convection cells the size of Texas rising and falling, with loops of superheated gas arcing hundreds of thousands of kilometers into space. And sometimes those magnetic fields tangle. They twist and reconnect in configurations that can't hold. And when they snap, when they release their stored energy all at once, the sun throws a tantrum that can reach Earth. We call them solar flares. Coronal mass ejections, space weather, gentle. Terms for something that could end technological civilization in hours. You wouldn't see it coming. Not really. The light from the sun takes 8 minutes to reach Earth, which means the first indication that a massive solar flare has erupted would arrive at exactly the same time as the flood of X-rays and extreme ultraviolet radiation that precedes the main event. 8 minutes. That's all the warning you'd get. 8 minutes from the moment astronomers detect the flare to the moment the electromagnetic pulse begins destroying satellites, power grids, and every piece of electronics not specifically hardened against such events. And then, 15 to 18 hours later, the real danger arrives. The coronal mass ejection. Billions of tons of magnetized plasma hurled into space at speeds up to 3,000 kilometers per second, reaching Earth and slamming into our magnetosphere with the force of billions of nuclear weapons. This has happened before, we know it can happen again, and when it does, we might lose everything that makes modern civilization possible. Let's understand what we're facing. Let's map the destruction before we learn whether we can survive it. The sun's surface is not solid. It's plasma, ionized gas so hot that electrons have been stripped from atoms, creating a sea of charged particles. This plasma is threaded through with magnetic fields generated by the sun's rotation and internal dynamics. These magnetic fields are not static. They're constantly shifting, moving, interacting. Where fields of opposite polarity meet, they can reconnect, snap together like rubber bands under tension suddenly released. When this happens on a massive scale, the energy release is staggering. In seconds, a region of the sun's surface can release the energy equivalent of millions of hydrogen bombs. That energy accelerates particles to near light speed, heats plasma to tens of millions of degrees, and sometimes, launches enormous bubbles of that plasma into space. These are coronal mass ejections, CMEs, billions of tons of solar material, magnetized, electrically charged, expanding outward from the sun in all directions. Most CMEs miss Earth. The sun ejects them in random directions, and space is vast. We occupy a tiny fraction of the sphere surrounding the sun, so most solar eruptions pass us by, harmless, unnoticed except by spacecraft designed to monitor the sun. But occasionally, perhaps once or twice per solar cycle, which lasts about 11 years, a CME heads directly toward Earth, and if it's powerful enough, if the magnetic field it carries is oriented the right way, it can cause what we call a geomagnetic storm. Usually these storms are minor. Beautiful auroras appear at high latitudes as charged particles interact with Earth's atmosphere. Satellites experience minor disruptions. Radio communications are briefly affected. We notice, we observe, we move on. But sometimes, rarely, but not impossibly, the storm is not minor. Sometimes the CME is so powerful, so perfectly aligned, that it overwhelms Earth's magnetic defences and induces electrical currents in everything conductive on the planet's surface. Power lines, transformers, undersea cables, pipelines, railroad tracks, anything metal, anything conducting becomes a giant antenna for geomagnetic disturbances, and currents flow through them that they were never designed to handle. This is called a geomagnetically induced current event, a GIC event, and if it's powerful enough, it can destroy the electrical infrastructure of entire continents in hours. It happened in 1859. We call it the Carrington Event, named after the astronomer who observed the solar flare that caused it. On September 1st, 1859, Richard Carrington was observing sunspots when he saw a massive white light flare erupt on the sun's surface. He noted it in his journal. He had no idea what was coming. 17 hours later, the coronal mass ejection reached Earth. The aurora borealis appeared as far south as the Caribbean. Telegraph systems across Europe and North America went haywire. Operators received electric shocks. Telegraph paper caught fire from the induced currents. Some telegraph systems continued operating even after being disconnected from their batteries, powered purely by the geomagnetic currents flowing through the wires. In 1859, this was mostly a curiosity. Telegraph systems were the extent of our electrical infrastructure. There were no power grids, no satellites, no computers, no GPS, no internet. The Carrington Event disrupted communications for a few days, sparked some fires, and then life continued mostly as before. If the Carrington Event happened today, we would not be so fortunate. Let's walk through what would happen hour by hour as a Carrington-class solar storm strikes modern Earth. Hour 0. Astronomers detect a massive X-class flare erupting on the Sun. Within minutes, they calculate its trajectory. It's Earth-directed. A coronal mass ejection is coming, and based on the flare's magnitude, it's going to be powerful. The fastest particles are already on their way. 8 minutes later, the X-rays and extreme UV radiation arrive. Satellites on the day side of Earth are immediately affected. GPS satellites experience increased drag from the expanding upper atmosphere, which heats and swells from the radiation. Some satellites lose their navigation lock. Others begin tumbling as their control systems are damaged by the sudden radiation dose. Communication satellites fail. Not all of them, not immediately, but enough. The International Space Station, if it still exists when this happens, experiences a radiation alarm. Astronauts retreat to the most shielded compartments and wait. On the ground, high-frequency radio communications fail across the entire daylight hemisphere. Airplanes lose contact with ground control. Ships at sea can't communicate beyond visual range. The military loses over the horizon. Radar. This is just the beginning. The main event hasn't arrived yet. 15 hours later, the coronal mass ejection reaches Earth. The magnetosphere, Earth's protective magnetic bubble, compresses violently as billions of tons of magnetized plasma slam into it. The aurora appears not just at the poles but across mid-latitudes. Beautiful, yes, but a sign of catastrophic magnetic disturbance. Deep underground, in power stations and substations across North America, Europe, Asia, alarms begin to sound. Geomagnetically induced currents are flowing through the grid. Transformers, designed to handle alternating current at specific frequencies, are experiencing direct current surges. They begin to overheat. Operators try to compensate. They disconnect parts of the grid, trying to isolate damaged sections. But the currents are too widespread, too powerful. Transformers fail. Not one or two, dozens, then hundreds. Each failure cascades, forcing other parts of the grid to handle loads they weren't designed for, causing more failures. Within 3 hours, power grids across entire continents go dark. Not from lack of generation, power plants are still running, but from lack of transmission. The transformers that step voltage up and down, that move electricity across long distances, are destroyed. And transformers are not simple devices. They're custom-built, enormous, often taking months to manufacture and replace. The lights go out, not just household lights, everything. Water pumping stations stop. Sewage treatment plants fail. Cell towers, after their backup batteries drain in hours, go silent. Gas stations can't pump fuel. Hospitals switch to generators, but those generators need fuel, and fuel can't be delivered without working logistics networks. Refrigeration stops. Food spoils. In summer, people begin dying from heat within days. In winter, from cold. The supply chain, the invisible network that keeps modern civilization fed and functioning, collapses. This is hour 18 of the solar storm, and it's only just beginning. Let's talk about satellites, because their destruction would be both immediate and catastrophic. Earth orbit is home to thousands of active satellites. Communication satellites, weather satellites, GPS satellites, scientific satellites, military satellites, spy satellites, the International Space Station, a vast infrastructure in space that we've come to depend on without even thinking about it. A Carrington-class solar storm would cripple many of these satellites. The intense radiation would damage solar panels, reducing power generation. It would corrupt computer memory, causing software failures. It would charge the satellite's structure, creating potential differences that could arc across circuits, destroying electronics. Some satellites would survive, those designed with radiation hardening, those in particularly protective orbits. But many wouldn't, especially the commercial satellites built to a budget, designed for normal space weather, not extreme events. GPS fails first. The satellites themselves might survive, but their atomic clocks, critical for the precise timing that GPS navigation requires, would be disrupted by the radiation. Position accuracy degrades from meters to kilometers. Precision agriculture fails. Automated shipping containers can't track themselves. Military operations lose precision targeting. Then communication satellites fail, the ones in geostationary orbit. 36,000 kilometers above the equator are particularly vulnerable. They're far from Earth's protective magnetosphere, exposed to the full fury of the solar storm. They experience years' worth of radiation damage in hours. Global communications collapse. No satellite TV, no satellite internet. International phone calls route through undersea cables, but those cables are experiencing their own problems from geomagnetically induced currents. Many fail. Weather satellites go dark. We lose the ability to forecast storms, to track hurricanes, to monitor climate. We're flying blind, meteorologically speaking, at precisely the time when we most need accurate weather data to coordinate recovery efforts. The International Space Station, if crewed when the storm hits, faces a desperate situation. Radiation levels inside the station spike. Astronauts retreat to the most shielded areas, typically the sleeping quarters, surrounded by supplies and equipment that provide some protection. They wait, experiencing radiation doses that increase their lifetime cancer risk, hoping the station systems survive. If they're lucky, they do. If they're not, if critical systems fail, if life support is compromised, they have limited time to evacuate via whatever spacecraft are docked, and those spacecraft have to navigate through radiation and debris, through a space environment that's become actively hostile. This is what happens in orbit. On the ground, things are worse. Let's focus on a city, any major city. New York, London, Tokyo, Mumbai. It doesn't matter. They all face the same cascading failures. Hour 20. The power is out. It's been out for 2 hours now, and people are starting to realize this isn't a normal blackout. Their phones don't work. Cell towers are down. The internet is gone. Radio is static. They're isolated, cut off from information, trying to understand what's happening. Those with battery-powered radios might hear emergency broadcasts if any stations are still operating. Stay in your homes. Do not attempt to travel. This is a widespread power outage caused by solar activity. Authorities are working to restore power. But authorities are overwhelmed. They have no power either. Their communications are down. Their coordination is gone. Local emergency services fall back on pre-digital protocols, if anyone still remembers them. Hour 24. Water pressure is dropping. The pumps that maintain pressure in the water distribution system run on electricity, and backup generators are running out of fuel. Soon, taps run dry. In summer, this is a crisis. People need water. Without it, they start dying in days. Sewage systems back up. Modern cities are designed with the assumption of constant water flow and powered pumping. Without power, sewage doesn't flow uphill. It pools, backs up into basements, into streets. Disease risk skyrockets. Hour 48. Food is becoming a problem. Refrigeration has been out for 2 days. In summer, everything perishable is spoiled. Grocery stores can't receive new shipments. Trucks can't navigate without GPS. Can't fuel without working gas pumps. What food remains in stores is being looted. Police can't respond effectively. They have no communications, no coordination, limited fuel. Social order begins to fracture. Not everywhere, not all at once. Many communities pull together, sharing resources, organising locally. But in some places, especially large cities where population density is high and resources are scarce, violence erupts. Hour 72. Hospitals are in crisis. Those with generators are running out of fuel. Those without are operating in the dark with no refrigeration for medications, no electronic monitoring of patients, no way to sterilise equipment without power. People with chronic conditions requiring electricity, dialysis, ventilators, insulin refrigeration, are dying. Emergency services have collapsed. Fire departments can't respond. No fuel for trucks, no water pressure for hoses. Fires burn unchecked. Medical emergencies go unanswered. Crime escalates as police forces, overwhelmed and under-resourced, fall back to protecting critical infrastructure. This is 3 days after the solar storm hit. And the transformers are still destroyed. Power restoration will take not days, but weeks, perhaps months, perhaps longer. Let's talk about the economic impact, because it's almost incomprehensible. A National Academy of Sciences study in 2008 estimated that a Carrington-class event today could cause $1 to $2 trillion in damage in the first year alone, with full recovery taking 4 to 10 years. That's a conservative estimate. It assumes that replacement transformers exist somewhere, that they can be manufactured and transported and installed. It assumes that the social order holds together long enough for recovery to happen. Those assumptions might not hold. High-voltage transformers are not mass-produced. They're custom-built for specific substations, often taking 12 to 18 months to manufacture. There's no large stockpile sitting in warehouses. The global supply chain for these components is fragile, dependent on the very electrical infrastructure that would be destroyed. If hundreds of transformers fail simultaneously across a continent, there may not be enough manufacturing capacity worldwide to replace them in any reasonable time frame. Especially if the solar storm affects multiple continents, which it would, given that CMEs can impact the entire dayside of Earth. Recovery would be slow, painfully, catastrophically slow. Regions might be without power for years, not months, and in those years, without electricity, modern civilization cannot function. Agriculture collapses. Modern farming depends on electricity for irrigation, for processing, for refrigeration, for transportation. Without it, we revert to pre-industrial productivity, which cannot support current population levels. Famine follows, not immediately. There are stockpiles, reserves. But within months, as reserves are exhausted and new production fails to materialize, as distribution networks remain broken, people starve. The global population, which has grown to 8 billion, largely because of technologies that depend on electrical power, cannot sustain itself without that power. The die-off would be catastrophic. Billions could die within the first year. Not from the solar storm directly, from the social and agricultural collapse it triggers. This is not science. Fiction. This is a plausible scenario based on the known effects of geomagnetic storms on electrical infrastructure and our complete dependence on that infrastructure. The sun doesn't know or care that we've built our entire civilization on a foundation that could be destroyed by a natural event it produces regularly. Let's talk about how we got here, how we became so vulnerable, because understanding our dependence on electricity helps us understand the magnitude of the threat. 200 years ago, the Carrington Event was an inconvenience. Today, it would be an existential threat. What changed? We did. We built a civilization that cannot function without constant electrical power. Consider your daily life. You wake to an electric alarm. You shower with water pumped electrically. You eat food that was refrigerated, transported using electric logistics networks, purchased in stores with electric payment systems. You communicate via devices that require electricity and network, infrastructure powered by electricity. You travel in vehicles that, even if gasoline-powered, depend on electric fuel pumps, traffic lights, GPS navigation. Your work, whatever it is, almost certainly requires electricity. Your entertainment requires electricity. Your heating and cooling require electricity. Your access to information, to news, to connection with others, all require electricity. We've built redundancy into none of this. We've assumed the grid will always function, that power will always be available, that the sun will continue to be benign. That assumption is wrong. The sun has never been benign. We've just been lucky that its most violent outbursts haven't occurred during the brief period, less than 150 years, that we've had electrical infrastructure vulnerable to geomagnetic storms. Our luck is statistical. It's not guaranteed to continue. Solar cycles last about 11 years, from solar minimum, relatively quiet, to solar maximum, more active, and back. During solar maximum, large flares and CMEs are more common. We've been through about 15 solar cycles since the Carrington Event. In those 15 cycles, we've had several close calls. In 1989, a geomagnetic storm knocked out Quebec's power grid for 9 hours. Not a Carrington-class event, but powerful enough to demonstrate vulnerability. In July 2012, a Carrington-class CME erupted from the sun. If it had happened a week earlier, Earth would have been in its path. We missed it by chance, by the rotation of the Earth and the timing of the eruption. If our orbit had been slightly different, if the sun had erupted days earlier, we would have experienced a Carrington event in 2012. We didn't. We got lucky. But luck is not a strategy. Let's talk about detection and warning systems, because you might think we can see these events coming, that we have time to prepare. We do have detection. NASA and NOAA operate satellites that monitor the sun constantly. The Solar Dynamics Observatory, the Solar and Heliospheric Observatory. These satellites watch for flares, for CMEs, for any signs of solar activity that might affect Earth. When a major flare erupts, we know within minutes. We can calculate whether a CME is Earth-directed. We can estimate its speed and arrival time. We can issue warnings. But warnings are only useful if there's something you can do with them. For a Carrington-class event, you'd have perhaps 15 to 24 hours between detecting the CME and its arrival at Earth. What can you do in that time? You can't shut down the power grid. Not globally. Not safely. Power grids are complex systems designed to run continuously. Shutting them down requires careful coordination, gradual reduction of load, ensuring that generation matches consumption at every moment. You can't just flip a switch. And even if you could shut down the grid, the geomagnetically induced currents would still flow through the wiring, through the transformers sitting idle. Shutting down might reduce damage, but it wouldn't prevent it. You can put satellites into safe mode, perhaps. Orient their solar panels, edge onto the radiation, shut down non-essential systems, hope their shielding is enough to protect critical components. Some satellites would survive this, many wouldn't. You can warn people, tell them to stock up on water, food, medications, tell them to fill their gas tanks, withdraw cash, prepare for extended power outages. But 15 hours is not enough time for billions of people to adequately prepare, and the warning itself might trigger panic, might cause more harm than it prevents. So detection gives us awareness, but limited ability to mitigate. We can watch the catastrophe approaching. We can understand what's about to happen, we just can't stop it. This is a different kind of horror than gamma ray bursts or rogue black holes. Those threats are distant, abstract, unlikely on human timescales. Solar storms are immediate, certain to occur eventually, and we've already experienced close calls in living memory. The threat is not theoretical, it's real. It's coming. We just don't know when. Let's talk about what happens in the weeks and months after the power goes out, because the immediate crisis is just the beginning. Week 1. The first wave of deaths has already occurred. People dependent on electrical medical devices, elderly people in heat waves or cold snaps, accidents from the sudden loss of traffic lights and coordination. Urban areas are becoming unstable. Cities designed for populations that can be fed and supplied through just-in-time logistics. When those logistics fail, when food stops arriving, when water stops flowing, cities become death traps. Some people evacuate. They take what they can carry and walk, because cars are useless without fuel. They're heading for rural areas, for farms, for anywhere that might have food and water. The roads are clogged with abandoned vehicles with refugees. Rural areas, initially better, off, face their own challenges. They might have wells and generators, might have food stores, but they're being inundated by urban refugees, by desperate people who need resources. Conflicts emerge over access to food and water. Governments, where they're still functioning, declare martial law. Military units are deployed to protect critical infrastructure, power plants, water treatment facilities, food warehouses. But the military has limited fuel, limited communications, limited ability to coordinate. They're effective locally but can't project power beyond their immediate areas. Week 2. Diseases emerging as a major killer. Without sewage treatment, without clean water, cholera and dysentery spread rapidly. Hospitals, even those with fuel for generators, are overwhelmed. Medications are running out. Antibiotics, insulin, chemotherapy, drugs. All require refrigeration or electrical manufacturing processes that are no longer available. People with chronic conditions are dying. Diabetics without insulin. Heart patients without their medications. Anyone requiring dialysis. The death toll is climbing into the millions, perhaps tens of millions globally. Opportunistic infections flourish. Without refrigeration, food poisoning is common. Without clean water, waterborne diseases explode. Without functioning medical systems, minor injuries become life-threatening. Social order continues to fray. In some communities, people band together, organize mutual aid, share resources. These communities might survive. In others, it's chaos, looting, violence, complete breakdown of civil authority. Month 1. By now, the scale of the catastrophe is clear to anyone who survived. This is not a temporary disruption. The power is not coming back soon. Transformers are not being replaced because they can't be manufactured without electrical infrastructure. Governments are trying to restore power in a few critical areas. Major cities, military bases, manufacturing centres. But progress is slow. Each restored section of grid needs transformers, needs fuel, needs coordinated effort, and the skilled workers who know how to do this restoration are scattered, unreachable, or dead. Agriculture is collapsing. It's the wrong season in much of the world, either too early or too late for planting. Even where planting is possible, modern farming equipment doesn't work without fuel, which requires electrical pumps. Farmers revert to hand tools, to animal power where animals are available. Productivity drops by 90% or more. The food that does exist can't be distributed. There's no refrigerated transportation, no logistics network. Local communities might have food. Regions 100 kilometers away are starving. And there's no way to move food from surplus to deficit areas. Famine begins, not everywhere at once, but spreading. Urban areas first, then regions that depend on food imports. The die-off accelerates. Month 3, the global population has dropped significantly. Exact numbers are impossible to know, There's no functioning census, no communications that would allow counting, but estimates suggest hundreds of millions dead, perhaps more than 1 billion. The survivors are adapting. Communities that can produce food locally, that have water sources, that have maintained order, they're establishing a new normal. Pre-industrial agriculture, barter economies, local governance. This is not civilization as it was. This is something else. A regression to conditions that haven't existed in the developed world for a century or more. And in the southern hemisphere, in nations that were less dependent on electrical infrastructure, that had more resilient local systems, things are slightly better. But only slightly. The global economy has collapsed. There's no international trade, no way to transport goods between continents. Everyone is isolated, local, struggling to survive. Year 1, power is returning in some areas, small grids, isolated from each other, powering critical facilities. But these are islands in a sea of darkness. Most of the world remains without electricity. The population continues to drop. Famine, disease, violence. The death toll is catastrophic. Some estimates suggest the global population could fall to 3 or 4 billion within the first year. Perhaps lower. This is the cost of a Carrington event striking our modern, electrically dependent civilization. Not destruction of the planet, not extinction of humanity, but the collapse of the systems that support our current population levels. The survivors would rebuild, eventually, over decades. But the civilization that existed before the storm would be gone, and what emerges in its place would be something different, harder, more aware of its vulnerability to forces beyond its control. Let's talk about why we haven't protected ourselves, because the solutions exist. We know how to harden transformers against geomagnetic storms. We know how to design grids with redundancy and protection. We know how to build satellites that can survive extreme space weather. We just haven't done it. Not at scale, not comprehensively. Why not? Cost primarily. Hardening the electrical grid would require replacing or retrofitting thousands of transformers, installing protective devices, redesigning distribution systems. The estimates range from tens of billions to hundreds of billions of dollars, depending on the level of protection desired. That's a lot of money to spend on a threat that might not materialize for decades or centuries. Politicians operate on election cycles, on budgets that need to show immediate returns. Spending billions to protect against a solar storm that might happen in 50 years is politically difficult when there are immediate needs competing for the same resources. There's also the problem of coordination. Power grids cross state lines, national boundaries. Protecting them requires international cooperation, standardized protocols, shared costs. That's hard to achieve even for immediate threats, let alone hypothetical ones. And there's complacency. We've been through several solar cycles without a major event. We had the close call in 2012, but nothing happened. It's easy to believe we'll continue to be lucky, that the odds are in our favour. The odds are in our favour on short timescales. Any given year, the probability of a Carrington-class event is very low, perhaps 1% or less. Over a decade, still low. But over a century, over the entire duration of our electrical civilization, the probabilities accumulate. What's unlikely in any given year becomes likely over long enough timescales. And the longer we wait without experiencing such an event, the more complacent we become, even though our vulnerability increases as we become more dependent on electrical infrastructure. We're playing Russian roulette with the sun. The chamber has many empty spaces, the gun won't fire. Most of the time we pull the trigger. But we're pulling the trigger every year, every solar cycle, and eventually we'll hit the loaded chamber. When we do, the cost of our complacency will be measured in lives, millions of lives, perhaps billions. Let's talk about the psychological impact of living with this knowledge, because once you understand the threat, once you recognize how vulnerable we are, it changes how you see the world. Every time you turn on a light, you're depending on a system that could fail catastrophically if the sun has a bad day. Every time you use your phone, You're relying on infrastructure that exists only because we've been lucky so far. This creates a strange kind of tension. You know the threat is real, you know it could happen tomorrow, but you also know it probably won't happen tomorrow, that the odds of any specific day being the one when the sun throws a Carrington-class CME at Earth are tiny. So you live normally, you use electricity, you depend on the grid, you make plans that assume continuity of modern infrastructure. Because what else can you do? You can't live in constant crisis mode, can't maintain that level of anxiety indefinitely. But underneath the normalcy, there's awareness. Every solar storm alert, every news story about space weather triggers a spike of concern. Is this the one? Is this when our luck runs out? Usually it isn't. The storm is minor, or it misses Earth, or our protection systems handle it adequately. And you relax, and life continues, and the awareness recedes back into the background. This is how you live with low probability, high consequence threats. You acknowledge them intellectually while not letting them dominate your emotional landscape. You prepare where you reasonably can. Maybe you keep extra water and food stored. Maybe you have cash on hand in case electronic payment systems fail. But you don't let the possibility of catastrophe prevent you from living. It's a balance between awareness and denial, between preparation and paralysis, between recognizing danger and still finding meaning in the present. And it's a balance humanity has always had to strike. Our ancestors faced threats they couldn't control. Droughts, floods, plagues, wars. They lived with uncertainty, with the knowledge that catastrophe could strike without warning. We're doing the same thing, just with different threats. The sun instead of the weather. Geomagnetic storms instead of marauding armies. But the fundamental challenge is the same. How do you live fully in the face of existential uncertainty? Let's talk about what we could do, both as individuals and as a civilization, to reduce our vulnerability. At the individual level, preparation is limited but possible. You can store water and non-perishable food. You can keep cash on hand. You can have a battery-powered radio to receive emergency broadcasts. You can know your neighbours, build community connections that might matter in a crisis. These preparations won't save you from a Carrington event, but they might help you survive the first days or weeks, might increase your odds of making it through the immediate crisis to whatever comes after. At the community level, there's more that can be done. Local governments can invest in backup power for critical facilities. They can stockpile emergency supplies. They can develop plans for maintaining order and distributing resources if the grid fails. Some communities are doing this. Some cities have resilience plans that account for extended grid outages, but many don't. Budget constraints, competing priorities, the sheer difficulty of planning for a scenario most people don't think about. At the national level, governments could mandate grid hardening, could require utilities to install protection systems, could stockpile replacement transformers. Some nations are beginning to do this. The UK, Australia, and others have programs aimed at improving grid resilience. But progress is slow. The electric utility industry is conservative, resistant to expensive changes that don't immediately improve service or profitability. Regulators struggle to balance safety with cost, to justify expenditures on protecting against events that might not occur for decades. And at the international level, cooperation is minimal. Space weather monitoring is shared. NASA and NOAA data are available globally. But there's no coordinated effort to protect infrastructure, no international agreement on standards or responsibilities. We're treating a global threat as a collection of local problems, and that fragmentation makes us more vulnerable than we need to be. The irony is that the technology exists. We know how to protect transformers. We know how to design satellite shielding. We know how to build redundancy into critical systems. We're not doing it because of choices, economic choices, political choices, social choices about what risks we're willing to accept and what investments we're willing to make. We're choosing vulnerability, passively through inaction, but choosing nonetheless. And one day, that choice will have consequences. Let's think about the sun itself, about what's happening on that fusion reactor 150 million kilometers away that makes these storms possible. The Sun is not a simple sphere of burning gas. It's a complex dynamic system with layers, with different regions rotating at different speeds, with magnetic fields generated by the motion of charged plasma in its interior. These magnetic fields emerge through the Sun's surface, creating sunspots, dark regions where the magnetic field is so strong it suppresses convection and cools the surface. Sunspots are not static. They move, they evolve, they interact with each other. When sunspot regions with opposite magnetic polarity approach each other, their fields can reconnect. This releases energy, sometimes small amounts, sometimes enormous amounts. The largest flares release 1032 joules, roughly 1,000,000 times the energy of all nuclear weapons on Earth detonated simultaneously. That energy accelerates particles, heats plasma, and sometimes launches coronal mass ejections, bubbles of magnetized plasma that expand away from the Sun at millions of kilometers per hour. We're getting better at understanding this process. Solar physicists can model magnetic field evolution, can predict which sunspot regions are likely to produce flares, but prediction is not perfect. We can identify high-risk regions, but we can't say with certainty when a flare will occur or how powerful it will be, and we definitely can't predict whether a CME will be Earth-directed. That depends on where the eruption occurs on the solar disk, on the angle of the ejection, on factors we can't measure until after the event has started. So we watch, we monitor, we hope to catch eruptions early and issue warnings, but we're reactive, not proactive. We can't prevent solar storms. We can only try to survive them. The Sun will do what the Sun does. It has no awareness of Earth, no knowledge that its eruptions affect us. It's just a star following the laws of physics, converting hydrogen to helium, generating magnetic fields through dynamo processes, occasionally releasing energy in bursts that ripple across the solar system. We happen to be in range. We happen to have built a civilization vulnerable to those energy bursts, and we happen to have no control over when the next one will occur. Let's shift perspective now. Let's move from the mechanics of destruction to the deeper questions about what it means to build a civilization on such fragile foundations. We've created something unprecedented in human history, a global civilization that depends entirely on a single technology, electricity, and that technology is vulnerable to a natural phenomenon we can neither predict precisely nor prevent. This is different from past, vulnerabilities. Ancient civilizations depended on stable climate, on predictable rivers, on conditions they couldn't control. But those dependencies were distributed. A drought might destroy one region while others survived. A flood might devastate a river valley but leave neighbouring areas intact. Our electrical dependence is global and simultaneous. A Carrington event doesn't respect borders. It affects entire hemispheres at once. The interconnectedness we've built, our strength in times of peace and prosperity, becomes our critical weakness in the face of solar storms. We've optimized for efficiency at the expense of resilience. Just-in-time supply chains reduce costs but eliminate redundancy. Centralized power generation is economical but creates single points of failure. Global communication networks enable coordination but depend on satellites vulnerable to space weather. Every optimization has made us more productive and more fragile simultaneously. This is not an accident. It's the result of economic pressures, of competition, of the drive to reduce costs and maximize efficiency. Resilience is expensive, redundancy is wasteful, stockpiles are inefficient, so we've minimized all of them, assuming that the systems we depend on will continue functioning indefinitely. That assumption works until it doesn't, until the Sun reminds us that we exist within a physical universe that doesn't care about our economic models or our efficiency metrics. The question is not whether a major solar storm will hit us. The question is whether we'll have built resilience into our systems before that happens, or whether we'll learn about vulnerability the hard way, through catastrophic failure and societal collapse. Current trends suggest we're choosing the hard way. We're building more dependence on electrical infrastructure, not less. Smart cities, Internet of Things, electric vehicles, autonomous systems, all wonderful technologies, all increasing our vulnerability. We're racing forward, building higher on a foundation we know could crumble. Because the alternative, slowing down, investing in protection, accepting short-term costs for long-term security, is politically and economically difficult. So we roll the dice, every year, every solar cycle, hoping our luck continues, knowing that eventually it won't. Let's talk about what would survive, because in the aftermath of a Carrington event, not everything would be destroyed. Some systems, some communities, some technologies would persist. Anything not connected to long-distance power lines would be largely unaffected by geomagnetically induced currents. Small-scale solar systems with local battery storage, isolated generators, hand tools, mechanical devices, communities that maintain some degree of self-sufficiency would fare better than those completely dependent on external supply chains. Rural farming communities with local food production, towns with their own water, sources, regions with local manufacturing capability, knowledge would survive, books, hard drives not connected during the storm, the collective understanding of how to do things, how to farm, how to build, how to organize. That knowledge would be invaluable in the reconstruction. And people would survive. Billions would die, yes, but billions would also live through the immediate crisis. Human resilience is extraordinary. We've survived ice ages, plagues, wars, famines. We would survive a solar storm's aftermath too. But survival is not the same as continuation. The civilization that exists after a Carrington event would be different from the one that existed before. Smaller, more localized, more aware of its vulnerability. Would that be entirely bad? There's an argument, admittedly one easier to make from the comfort of functioning electrical infrastructure, that our current civilization is unsustainable anyway, that we're consuming resources, producing waste, and growing population in ways that will lead to collapse regardless of solar storms. A Carrington event would force a reset, not a chosen one, not a planned transition to sustainability, but an imposed one, sudden, catastrophic, but potentially leading to a civilization more aligned with what the planet can actually support. This is not an argument for welcoming solar storms. The human cost would be unacceptable, but it's worth considering that vulnerability to space weather is just one of many vulnerabilities our current trajectory has created. We're vulnerable to climate change, to resource depletion, to pandemic, to nuclear war, to artificial intelligence mishaps. We've built a complex, interconnected, optimized civilization that's fragile in ways we don't fully understand and aren't adequately preparing for. Solar storms are just one item on a long list of potential catastrophes. They're notable because they're purely natural, because we bear no responsibility for their occurrence. But our response to them, our lack of preparation, our complacency, our prioritizing of short-term efficiency over long-term resilience, that's all too human. Let's think about consciousness in this context, about what it means to be aware of threats like solar storms and to choose, collectively, not to adequately protect against them. We know the threat is real. Scientists have studied it, quantified it, warned about it. The reports exist. The National Academy of Sciences study. The UK government's space weather risk assessment. Academic papers analysing geomagnetically induced currents and grid vulnerability. The knowledge is available. We're not ignorant. We're aware. And yet we don't act. Not adequately. Not at the scale needed to actually protect our civilization. Why? Part of it is the challenge of acting on low probability, high consequence risks. Human psychology is not well suited to this. We're good at responding to immediate visible threats. We're terrible at preparing for things that might happen eventually but probably won't happen soon. This is why people don't save for retirement until it's almost too late. Why we don't address climate change with urgency. Why we don't build resilience against pandemics until one is already spreading. We're reactive, not proactive. We respond to disasters, we don't prevent them. It's not a flaw exactly. It's how we're wired, how we evolved in environments where immediate threats were more dangerous than distant ones. But in the modern world, that wiring is maladaptive. The threats we face, climate change, pandemic, solar storms, asteroid impacts, operate on timescales our instincts don't handle well. We need to act now to prevent catastrophes that might occur in decades. But now is when we have other pressing concerns, immediate needs, limited resources, and decades is an abstraction, easy to defer, easy to leave for future generations. So we drift toward catastrophe, aware but inactive, understanding but not acting, until the disaster occurs and we're forced to respond. This is not inevitable. We could choose differently. We could invest in resilience, in protection, in preparing for low probability risks. But that requires collective will, political leadership, sustained commitment over timeframes longer than election cycles. It requires treating future generations as if they matter as much as current ones. It requires accepting costs today for benefits that might not materialize for decades or centuries. These are hard asks. Not impossible, but hard. And so far we're not meeting them. Let's talk about the experience of being conscious in a universe where the sun can destroy our civilization without warning or malice. There's something profoundly unsettling about this. We like to think we have agency, control, the ability to shape our future through choices and actions, and in many domains we do. But not here, not with the sun. We can't negotiate with it, can't deter it, can't make it care about our existence. It will do what stars do, follow the laws of physics, produce flares and CMEs. According to magnetic field dynamics, we can observe but not control. Our only agency is in how we prepare, how we build resilience, how we respond when the inevitable occurs. But even that agency is limited by politics, economics, collective action problems. As an individual, you can prepare personally, store food and water, learn skills that don't require electricity, build community connections. These are good things to do, valuable, regardless of whether a solar storm occurs. But you can't protect the grid yourself. You can't harden the transformers in your region. You can't ensure that satellites are radiation hardened or that your government has adequate emergency response plans. Those require collective action, and collective action is hard, slow, often ineffective until a crisis forces change. So you exist in this strange state, aware of a threat, understanding its magnitude, recognizing your individual powerlessness to prevent it, and uncertain whether collective action will occur before the threat materializes. It's a microcosm of many modern challenges: climate change, biodiversity loss, antibiotic resistance, nuclear proliferation, risks we understand, risks we could address, risks we're not adequately addressing because of coordination failures and short-term thinking. Solar storms are just the most literal version of this pattern, a visible threat from a specific source that we're watching approach in slow motion, while not doing enough to protect ourselves. How do you live with this knowledge? How do you maintain hope, maintain engagement, maintain the will to build and create when you know that a natural event could destroy it all? The same way humans have always lived with uncertainty and vulnerability. By focusing on what you can control, by finding meaning in the present, by creating and loving and experiencing despite knowing it's all temporary. You can't stop the sun from producing flares. You can still live fully, can still contribute to your community, can still experience beauty and connection and wonder. The solar storms don't negate the value of what you do. They just remind you that permanence was never the point. The point is the doing, the experiencing, the being. And if a Carrington event occurs, if the power goes out and civilization collapses, what you've experienced, what you've created, what you've meant to others, that will have been real, will have mattered, regardless of whether it persists. This is not comforting in the conventional sense, but it's true, and truth even uncomfortable truth, is more valuable than false comfort. Let's talk about what comes after, assuming humanity survives a Carrington event and begins rebuilding. The rebuilding would be different. We'd have collective memory of what happened, understanding of why it happened, motivation to prevent recurrence. The new electrical infrastructure as it's built would be hardened against geomagnetic storms. We'd also likely be more distributed, more localized. The global just-in-time supply chains wouldn't return. They'd be recognized as too vulnerable. Instead, regional production, local redundancy, smaller-scale systems that can function independently. Communication networks would be redesigned with resilience in mind. More underground cables, less reliance on satellites, more local mesh networks, less dependence on centralized hubs. Agriculture would maintain more traditional methods alongside modern ones, not abandoning technology, but keeping the knowledge and skills of pre-industrial farming as backup, as insurance against future disruptions. This wouldn't be regression exactly, it would be learning, taking the lessons of catastrophe and incorporating them into how we build, how we organise, how we think about risk and resilience. We'd probably be more conservative about adopting new dependencies, more careful about creating single points of failure. Having experienced the cost of fragility, we'd value robustness more highly. Would we maintain this awareness? Or would future generations, removed from the trauma, drift back toward optimization and efficiency at the expense of resilience? History suggests we forget. The societies that survived plagues didn't maintain pandemic preparedness indefinitely. The cities that rebuilt after earthquakes eventually stopped earthquake-proofing new construction to save costs. Human memory is short, institutional memory even shorter. Within a few generations, the Carrington event would be history, then legend, then a cautionary tale that some people take seriously and others dismiss as exaggerated, and we drift back toward vulnerability. Different vulnerabilities perhaps, but vulnerability nonetheless. This is the cycle: catastrophe, response, preparation, complacency, vulnerability, catastrophe again. We can try to break the cycle, can try to maintain awareness and preparation across generations, but it's hard. It requires constant effort, constant vigilance, constant spending on protection against threats that haven't materialized yet. Can we do it? Maybe, if we choose to. If we decide that resilience matters enough to invest in it, even when times are good, even when the threat seems distant. But that requires wisdom, long-term thinking, collective commitment to protecting future generations. These are not humanity's strengths, not historically, not currently, so we'll probably learn the hard way, again, as we have before, as we likely will again. Let's drift toward quieter contemplation now, toward acceptance not of complacency but of reality. Solar storms will happen. Major ones, Carrington-class events will occur again, not every year, not even every decade, but eventually. The sun's magnetic dynamics guarantee it. When they occur, they will affect Earth. We can't shield the planet. We can't deflect coronal mass ejections. We can only prepare our infrastructure to withstand them, or accept the consequences when they hit unprepared systems. Currently, we're largely unprepared. Our grids are vulnerable. Our satellites are vulnerable. Our civilization is vulnerable. This might change. We might invest in hardening, in resilience, in protection. But we might not. Political will is fickle. Budgets are limited. Competing priorities are many. Regardless of what we do or don't do collectively, you individually can find peace with this situation. Not by denying the threat, that's false peace, built on ignoring reality, but by accepting that you exist in a universe where suns produce storms, where civilizations are vulnerable, where catastrophes occur despite our best efforts to prevent them. This has always been true. Our ancestors faced threats they couldn't control. Plagues, droughts, invasions, the unpredictability of weather and harvest. They lived anyway. They found meaning anyway. They created, loved, built, experienced. You can do the same. You can acknowledge the vulnerability while not being paralyzed by it. You can prepare reasonably while not obsessing. You can live fully while knowing that fullness is temporary. The sun will do what the sun does. You'll do what humans do. Adapt, survive, find meaning in the present. That's enough. It has to be enough, because it's all any of us have ever had. Solar storms are part of the context of existence, like mortality, like uncertainty, like the eventual heat death of the universe. Real, important, worth understanding. But not the focus, not the point, not the thing that should dominate your awareness or prevent you from experiencing the beauty and connection and wonder that are available in the present moment. The power is on now. The grid is functioning now. Your life is happening now. Live it. Fully, presently, with awareness of vulnerability, but without being defined by it. The sun watches, if stars can watch, indifferent, following physical law, occasionally violent in its expressions but never malicious, never personal, and you watch back, aware, understanding, vulnerable but not helpless, temporary but not meaningless. That mutual observation, the star and the conscious being, neither understanding the other, both existing according to their natures, is part of the strange beauty of the universe. The sun creates the conditions for life and occasionally threatens to destroy that life. We exist because of the sun and in spite of it. We're children of stellar nucleosynthesis experiencing awareness because of stellar light, while facing threats from stellar storms. It's paradoxical. It's uncomfortable. It's also how things are. And how things are is always more interesting, more nuanced, more worth engaging with than comfortable fictions about safety and permanence. Let's move into the deepest contemplation now, into the space where fear transforms into understanding, where vulnerability becomes acceptance, where the threat of solar storms takes its proper place in the larger context of what it means to exist at all. We've spent time with solar storms. We've examined the physics, understood the threat, contemplated the consequences. We've felt appropriate fear, acknowledged genuine vulnerability, recognized our civilization's fragility. Now it's time to integrate this knowledge, to find peace not through denial but through perspective. Start with this fundamental truth. You've always been vulnerable, not just to solar storms but to everything, to accident, to disease, to the unpredictable chaos of existence. Every breath you take depends on systems functioning, your heart, your lungs, your brain. Every moment of consciousness depends on conditions you don't control. Solar storms don't create this vulnerability. They just make it more visible, more cosmic in scale. They remind you that the stability you experience is contingent, temporary, dependent on factors far beyond human control. But contingent doesn't mean meaningless. Temporary doesn't negate value. The sunset is contingent on atmospheric conditions and planetary rotation. Does that make it less beautiful? Your life is contingent on countless variables aligning correctly. Does that make your experiences less real? The meaning is in the experiencing, not in the permanence of conditions. You are aware right now. You're thinking about solar storms, contemplating existence, experiencing what it's like to be conscious in a universe where stars can threaten civilizations. That awareness, that consciousness, that experience, it's happening regardless of what the sun might do tomorrow, and each moment of awareness is complete in itself, valuable for its occurrence, not for its duration. A solar storm could end your future moments, but your present moment, this one, right now, it's real, it's actual, it's happening. And nothing the sun does can erase the fact that this moment occurred, that you were conscious, that awareness existed here. Let's think about the sun differently now, not as a threat, though it is that, but as the source of everything you are. The atoms in your body were forged in stars. Not our sun, these atoms are older, created in previous generations of stars that lived and died before the solar system formed, but stars nonetheless. Fusion reactors like our sun, following the same physics, producing the same elements. The energy that powers your body comes from the sun. Plants capture sunlight through photosynthesis. Animals eat plants, or eat other animals that ate plants. All biological energy traces back to stellar radiation. The warmth you feel on your skin, the light that allows you to see, the seasonal cycles that structure life on Earth, all gifts from the sun. Without it, Earth would be a frozen rock in darkness, utterly lifeless. The sun creates the conditions for your existence. It also threatens that existence with storms. Both are true simultaneously. The sun is giver and destroyer, nurturing parent and potential executioner, the foundation of life and a source of existential threat. This paradox is not unique to the sun. It's fundamental to existence. The universe that creates consciousness also creates conditions that can end consciousness. The chemistry that allows life also allows death. The complexity that produces awareness also produces vulnerability. You can't have one without the other. Life requires specific conditions, and those conditions are inherently unstable, temporary, vulnerable to disruption. Solar storms are just one expression of this fundamental truth. Existence is precarious. Always has been. Always will be. The question is not how to eliminate the precariousness. You can't. The question is how to live fully despite it, how to create meaning in the face of vulnerability, how to be present for the experience of consciousness even knowing that experience is temporary and threatened. Let's talk about collective humanity now, about the shared project of civilization in the face of cosmic threats. We're 8 billion humans, scattered across a single planet, entirely dependent on that planet's continued habitability. We've built extraordinary things, cities, technologies, art, science, systems of cooperation that allow billions to coexist. And all of it is vulnerable to solar storms, to asteroids, to supervolcanoes, to our own weapons and technologies, to countless threats, both cosmic and self-created. Our civilization is a fragile, temporary structure built on a thin crust of rock orbiting an unstable star in a violent universe. It exists only because conditions have remained within survivable parameters for the brief time we've been building it. Those conditions will change. Maybe gradually, giving us time to adapt. Maybe suddenly from a solar storm or asteroid impact. But they will change. Does that fragility make our civilization meaningless? Or does it make it more remarkable? Consider what we've accomplished knowing at some level that it's all temporary. We build cathedrals that take generations to complete, knowing they'll eventually crumble. We write books intended for future readers, knowing future readers might never exist. We plant trees we'll never see fully grown, knowing they might be destroyed before they mature. We do this anyway. We create, build, preserve, despite knowing nothing lasts forever. Despite knowing that a solar storm or other catastrophe could end it all. That's not futility. That's courage. That's humans saying yes to existence despite uncertainty, choosing to engage with life despite its impermanence. You're part of that collective yes. Every day you participate in civilization, you're contributing to humanity's ongoing project of creating meaning in a universe that doesn't inherently provide meaning. The solar storms don't diminish this. They're just part of the context, part of the challenges we face as conscious beings trying to persist in a cosmos that's fundamentally indifferent to our persistence. Let's think about timescales again, but from a different angle. Our sun is about 4.6 billion years old. It's roughly halfway through its main sequence lifetime. In another 5 billion years, it will begin evolving into a red giant, expanding to engulf the inner planets, rendering Earth uninhabitable long before the sun actually swallows it. That's the ultimate deadline. 5 billion years from now, Earth ends. Not from a solar storm, but from the sun's normal evolution. In that context, solar storms are just minor fluctuations, Brief moments of violence in an otherwise steady stellar lifetime. The Sun will produce thousands, perhaps millions of major flares and CMEs over its remaining lifetime. Some will hit Earth, most won't. If we survive long enough, we'll experience many Carrington-class events. They're not anomalies. They're normal stellar behaviour, as inevitable as sunrise, as predictable as tides in their eventual occurrence, if not in their exact timing. This long-term perspective is both terrifying and comforting. Terrifying because it confirms that solar storms will happen, that vulnerability is permanent as long as we remain a single-planet species dependent on electrical infrastructure. Comforting because it places any individual event in context. Yes, a Carrington event would be catastrophic for current civilization, but it wouldn't end Earth, wouldn't sterilize the planet, wouldn't prevent life from continuing or humanity from rebuilding. We've survived worse. Our ancestors lived through ice ages, through supervolcano eruptions, through disasters that killed significant fractions of the human population. We're here because they survived, adapted, continued. We can do the same, not perfectly, not without tremendous cost, but we can endure, can rebuild, can learn from catastrophe and emerge changed but continuing. The Sun will outlive our current civilization. It will outlive any civilization we build on Earth. Eventually, if we persist long enough, we'll need to leave Earth entirely to become a multi-planet or even multi-star species. Solar storms are just early motivation for that journey. They're the universe telling us, don't put all your eggs in one basket. Don't depend entirely on one world, one star, one set of conditions. Distribute, diversify, become resilient through redundancy. If we listen, if we act on that message, solar storms will have served purpose. Not comfortable purpose. The lesson comes with real risk, real potential for catastrophe, but a purpose nonetheless. Let's talk about wonder again, because even in contemplating destruction, there's something magnificent about solar storms. The physics is extraordinary. Magnetic reconnection releasing energy equivalent to millions of nuclear weapons. Plasma accelerated to thousands of kilometers per second. Magnetic field lines stretched across millions of kilometers of space. Particles energized to near-relativistic speeds. This is nature operating at scales that dwarf human comprehension. The total energy in a major CME exceeds all the energy humanity has ever produced by orders of magnitude. We're watching forces that shaped planets, that drive stellar evolution, that operate on timescales from microseconds to billions of years, and we can understand it. Through physics, through mathematics, through observation and theory, we can comprehend what the Sun is doing, why it does it, what the consequences are. That understanding doesn't protect us. Knowledge isn't the same as control, but it's remarkable nonetheless. We're conscious beings, evolved on a planet made partly from stellar ash, capable of understanding the star that created those conditions. The Sun doesn't know we're here. It doesn't know it occasionally. Threatens us. It's not conscious, not aware, just following physical law. But we know it's there. We understand what it is, how it works, what it might do. We can observe its surface, measure its magnetic fields, predict its cycles if not its individual storms. That asymmetry, the star unconscious, the observer's conscious, is profound. The universe produced both, but only one can appreciate the other. Only one can wonder, can fear, can try to understand and prepare. You're that one. You're the conscious part of this system, the part that knows about solar storms and thinks about their implications and contemplates existence in their shadow. That's a gift, not safety. You were never offered safety, but awareness, understanding, the capacity to know the universe you inhabit, including its dangers. Use that gift, not just to fear, though fear is appropriate, but to appreciate, to marvel, to recognize the extraordinary physics you're witnessing, the cosmic processes you get to understand because you exist in this particular time, this particular place, with this particular consciousness. Solar storms are terrible and beautiful, dangerous and magnificent, a threat to civilization and a demonstration of the forces that created civilization's raw materials. Hold both truths, fear and wonder, vulnerability and appreciation, the threat and the beauty. That's maturity, that's wisdom, that's a complete relationship with reality rather than a filtered one that sees only danger or only beauty. Let's move towards silence now, toward the quiet acceptance that comes when understanding settles into peace. You know about solar storms, you understand the threat, you've confronted it directly, examined it from every angle, felt the appropriate emotions. Now you can let it settle. Not forget it, it's part of your knowledge now. But release it from the center of your attention. Let it take its proper place in the background. The sun is 150 million kilometers away. Billion. It's burning steadily, following the rhythms of its magnetic cycle, occasionally violent but mostly stable. It's been doing this for billions of years. It will continue for billions more. You're here, on Earth, living your life. The sun's behavior affects you. You need its light, its warmth, its stability. But you can't control it, can't change it, can't make it safe. All you can do is live, fully, presently, with awareness of the context but not dominated by it. The solar storms are part of the context, like mortality, like entropy, like all the other ways existence is temporary and vulnerable, real, important, worth understanding, but not the focus, not the point, not what your life is about. Your life is about whatever you're experiencing right now. Thoughts, sensations, connections with others, the quality of your awareness, the depth of your presence, the ways you create meaning in each moment. Solar storms can't touch that. They can end your future, but they can't diminish your present. They can destroy infrastructure, but they can't erase the experiences you've already had. What you've lived, what you've felt, what you've understood, that's real and permanent in the only sense that matters. It happened. It was actual. And its actuality is immutable. Find peace in that immutability, not in false promises of safety, but in the reality that your existence, however temporary, is real. You're here, now, conscious, aware, experiencing what it's like to be alive on a planet orbiting a star that occasionally storms. That's enough. That's everything. The sun watches if stars can watch. It burns, it fuses, it occasionally erupts. It doesn't know you exist, doesn't care whether you survive its tantrums, and you watch back. You understand what the sun is, even though it doesn't understand you. You're the conscious part of this relationship, the aware part, the part that can appreciate both the gift and the threat, be at peace with that. A symmetry. The star gives you life and threatens that life. The universe creates consciousness and creates conditions that can end consciousness. Both are part of the same package, the same reality. You don't get to choose which parts to keep and which to discard. You get the whole thing, the beauty and the danger, the creation and the destruction, the gift and the threat. Accept the whole thing. Not with resignation, but with clear-eyed recognition. This is how it is. This is how it's always been. This is reality, complete and unfiltered. And reality, even with its dangers, even with its vulnerabilities, is worth engaging with, worth experiencing, worth being present for. Sleep now or wake or continue your day, carrying this understanding lightly. The sun burns, the storms will come. Life continues in the spaces between storms. Be here for those spaces. Be present for the calm, for the stability, for the moments when the sun is just a star providing light and warmth, not a threat. Those moments are most moments, most days, most years. The storms are rare even if they're inevitable eventually. Live in the calm, appreciate the stability, create and love and experience while conditions allow. And if the storm comes, if the power fails, if civilization stumbles, face it as humans have always faced catastrophes, with resilience, with adaptation, with the fundamental human capacity to endure and continue. You're more resilient than you think. Humanity is more resilient than our fragile infrastructure suggests. We've survived worse than solar storms. We've rebuilt from ruins multiple times in our history. We can do it again if we need to. Not perfectly, not without loss. But we can continue, can persist, can create new civilizations from the ashes of old ones. That's the human story. Building, destruction, rebuilding, learning, adapting, continuing despite setbacks, despite catastrophes, despite all the ways the universe reminds us of our vulnerability. Solar storms are just the latest chapter in that story. Not the first threat we've faced, won't be the last. Just another challenge, another test of resilience, another opportunity to demonstrate that consciousness can persist despite the universe's indifference. Be at peace with your place in this story. You're one human among billions, living through one brief moment in a vast span of time. The solar storms were happening before you were born. They'll continue after you die. Your part is small, but real. Your consciousness matters even though it's temporary. Your experiences are valuable even though they'll end. Live that small, real, valuable existence fully, without needing it to be permanent to justify its value, without needing safety to permit engagement, without needing guarantees to choose presence. The sun burns, you're aware, and in that awareness, brief and fragile as it is, the universe knows itself. That's the miracle. Not that you're safe, you're not. Not that you'll last forever. You won't. But that you exist at all, that consciousness arose from stellar ash and planetary chemistry, that for a brief time the cosmos can observe itself through your eyes. Solar storms threaten that miracle, but they can't erase it. The awareness has occurred, the consciousness has existed, the universe has known itself through you and through billions of others. That knowing is complete in each moment, doesn't require continuation to be real, doesn't need permanence to matter. You've contributed to the universe's self-knowledge. Every moment of your awareness adds to the sum total of consciousness that has existed. And that sum can only increase, never decrease. Solar storms can prevent future additions. They can't subtract what's already been added. Rest in that permanence. The permanence of having existed, of having been conscious, of having participated in the grand mystery of awareness. The sun storms onward through space, following magnetic field, dynamics, occasionally violent, mostly steady. It creates and threatens, gives and potentially takes, enables life and endangers it. You observe from here, briefly, a temporary pattern of consciousness made possible by stellar light and threatened by stellar storms. Both are real, both matter, both are part of the complete picture of what it means to exist in this universe, on this planet, in this moment. Accept both. Fear and wonder, vulnerability and resilience, the threat and the beauty, the temporary nature of everything and the value of each moment despite that temporariness. This is wisdom. This is peace. This is how you live fully in a universe that contains solar storms and conscious beings and the strange, beautiful, dangerous relationship between them. The power flows now. The grid functions now. The sun is calm now. Be here for now. That's all you ever really have. All you ever really need. The storms will come when they come. You'll face them when you face them. Until then, and even then, if you survive, there's life to be lived, awareness to be experienced, meaning to be created. Do that, be that, experience that, for as long as the sun allows, for as long as consciousness persists, for as long as now continues to become the next now. That's enough. That's everything. The sun and the consciousness it enables, dancing together in the vast emptiness of space, neither permanent, both extraordinary, creating between them the conditions for this moment, this awareness, this experience of being alive and conscious and present. Be grateful for it. Not despite the storms, but including them. The whole package, the complete reality. This is what existence offers. Beauty and danger, creation and destruction, stability and storm. Take it. All of it. With open eyes and open heart and full presence, and live.